Hi everyone, Lou here with the second of the 4 videos covering components in a typical FRC robot. So, what makes the motor go? What controls the motor? Well, a motor controller. So let's talk a little bit about the electronics. What you're staring at here is a maze of wires, and I'll be the first to admit that it's not the prettiest thing. But it is fairly serviceable, meaning we can get in here and make changes, make repairs, and so on if we need to. Okay, so there's always a fine line between something that's beautifully neat, but maybe harder to service and repair, and something that's maybe a little bit more messy, but a whole lot easier to work with. So, for instance, these connections here have slack on purpose, because if there was no slack, then it'd be more difficult for us to service them, to pull them in, and to remove them or to replace them. Okay, so these things here are motor controllers. All right, the ones that they had numbers on them so that we can identify what's what. But those are Talon SRX controllers. You can see there's 1, 2, 3, 4, 5, 6, 7, and 8. There's actually another one mounted somewhere else, but. So what the motor controller does is it takes power, which is the red and the black wire right here. It takes power, and it takes a signal. In this case, it's coming off of this green and yellow wire called the CAN bus. So the commands go over the CAN bus. The 12 volts comes in here, and the commands actually tell the controller what to do with this 12 volts. On the output side, you see a green and a white wire. These go to a particular motor. So the wires will tell this motor controller and say, hey, I want you to go full speed forward, or half speed backwards, or I want you to stop, or I want you to, and the commands go into these, gets interpreted by the motor controller, which then does the right thing. Now, if you look at, so these wires going out go to the motor, and we have these connectors here. Let's see these snap in and out, so we can replace the cables. The green wire is the green and white wires are the wires that come with the motor controller, but of course they're not as long as we need them to be, so we have to add extensions to them. On the input side, these go into this board, and what this board does is this is the power distribution panel, and what it does is it takes each set of power lines going to a controller, and it provides a circuit breaker for it. Okay, so these breakers are all different sizes. Some are 20 amps. This is a 40 amp breaker. This is a 30 amp breaker, and so that's the protection in case something goes bad. Let's see. Now, power going into the power distribution panel is down here, actually behind the sticker. Let me see if I can get a better view. So you see that the two fat wires right here, in the black and the red, the big ones. And they come down and they go straight to the battery by way of a master switch. Okay, so let's see if I can get a good view of that. So this cable here goes to the battery. Okay, on the other end of the battery, which sits right here, has a corresponding cable that goes in here. This is the master on-off switch. Okay, when you click this down, oops, hold on a second. So when you latch this, it's on. When you press the red button, it's off. Okay, so as you can see, power goes from the cable, the red wire cable goes to the switch, comes out of the switch, and that plus the black wire from the battery, together they go to the power distribution panel. And then from the power distribution panel, all that power gets distributed to all the motor controllers and the rest of the system as well. Okay? Now, there's more about this system than that I'm covering, but maybe we'll come back to it. Notice that we do try and label everything, because that's kind of important, especially when you have so many wires. You may easily forget which set of wires goes to where. So this is labeled as the climber, because that's the motor controller that operates our climber, conveyor, and so on. Okay, other parts on this board here. This is the VRM, the voltage regulation regulator module, and what it does is it too takes power from the PDP, and it supplies regulated 5 volts on this side, regulated 12 volts on this side, and those go out to other components that need the 5 volts and the 12 volts. Okay, and among its features is that it's able to do this. And even if we have a brownout condition, in other words, imagine you're driving this thing and you're putting a heavy load on it. So the voltage in the battery sags briefly, this thing will try and maintain the power that's necessary to keep the other components alive. In particular, of course, you want to keep the CPU alive. Okay, and we'll look at that in a second. This right here, okay, is a gyro. So we use that to maintain orientation, to tell us where the front of the robot is, how many degrees we've turned, and that's for the automation portion of the competition, the first, 15, 30 seconds, whatever it is, I forget. And it helps us navigate. And let's see. This is a relay. This is new for this past season. New meaning it's a new product that they've allowed us to use. So you send a signal to it on and off, and it literally turns the output on and off. Okay. Now there's another piece that comes off of the VRM. Let me come around to the other side. And I'm going to shoot straight. Nope, nope. Hold on a second. Okay. This little module here is a pneumatic control module. So it too gets power from the VRM, and its job is to control pneumatic devices, and we'll get to that later. Okay. Let's see. What else is there on the power side? All right, let's get to the rest of the electronics on this side of the robot. So, coming from the relay, we come up to this. This is the CPU, okay? And we call this the Robo-Rio. In the past, people used to call it the so-called brain. I never liked that term, so I don't use it. Let me take this away. All right, so this product right here, this in the plastic case, is made by National Instruments, or sometimes NI for short. And National is one of the really big sponsors of FIRST. This is actually a variant of a product that they call, I think what was it called? The MyRio product. So they have a commercial product called MyRio, and then they made this particular product just for FIRST and they call this the Robo-Rio. Rio, which is spelled R-I-O, is a reconfigurable input and output, which in this case is all these products have an FPGA, which is a programmable gate array. And so this particular device is programmed to have certain features. Now, this board you're staring at that says Rev Robotics is actually a board that's sitting on top of the Rio. So the Rio itself is sitting at, you can't see the center portion of it, okay? This board is sitting on top of it to give some additional features that we need. But if you look around, you'll see there's a USB stick here, which we use to log information. Yeah, I can see the stick better here. Okay, so when we have, as our program is running during a match, we send data and we write data to this USB stick. And then later, if we have a problem, we can look at the log data there and say, hey, here's what happened, and here's what went wrong, and so on. Power goes in through here, if I remember correctly, right? And here's that green and yellow wire, the CAN bus. So commands go out here to all these devices. So by the way, all these motor controllers share the CAN bus, among other things. And other things also share the CAN bus on the other side. Going down on this side, we have digital I/O. So these are single signals that give out a 0 or a 1. Okay. And then it's up to the device downstream from that signal to decide what to do with the 0 and what to do with the 1. These stickers, by the way, we put on because they're sponsors of FIRST, and we want to thank them for continuing to sponsor FIRST. On this side, although we don't use any of these pins. These are PWM, or pulse width modulation signals. These are often used to control things like servos. They can also be used to control motor controllers, although obviously we're not using them here. And on the bottom, let's see if we can see this. Here we have relays, and we have analog inputs. On this daughter board, which is by Rev Robotics called the Moore board, we have connections here. These are PWM signals that are plugged here instead of over there. That's just because of the way we wired it. And what else do we have? And we have some more I/O pins over here. Okay, so that's probably all there is to say about the RoboRio. Now, inside the RoboRio, what you don't see in there is a dual ARM core, we programmed this particular robot in Java, but you can write code in Java, C++, or LabVIEW. LabVIEW, for those who don't know, is a language developed by National Instruments, and it's actually very well supported by National Instruments, and it's actually very well mated with this product. Java and C++ are supported by a library called WPI-lib, which is created by students at WPI, hence its name. Now would be a good time to summarize the numerous features of the RoboRio. The unit supports 10 digital I/Os, 4 relay outputs, 4 analog inputs, and 10 PWM outputs. The I/O pins are usually used to check the state of binary sensors, such as a switch. Internally, there are quadrature encoders that use pairs of DIO pins, and these can be used to count shaft rotations. Analog inputs are used to measure voltages. An example would be a potentiometer that rotates when some mechanism moves. PWM outputs are typically used on servos and motor controllers. The RoboRio can control additional devices through the CAN bus, an I2C bus, and an SPI bus. It has connectivity through an RS-232 serial port, an Ethernet port, and both host and device USB ports. Lastly, it directly controls the robot signal light. And of course, there's room for an expansion board for connections to even more devices. Above this, there's this light, and every robot on FRC has this light. This is the, so this is the robot signal light. It has different flashing patterns to tell the rest of the world what's happening. Is the robot on? Is it working properly? Is it talking to the field management system? Is it not powered on at all? And so on. This is the open mesh radio, otherwise known as a Wi-Fi router. So communications to the robot is over Wi-Fi. So this is essentially a computer talking to another computer. The other computer being your driver's station. Okay? And it too gets power from via VRM. So what you see here, actually, this is actually the Ethernet cable going in. Okay. And this is actually using PPoE, so power over Ethernet, which is why the power socket here is not being used. Power and Ethernet are going through this cable. The green cable is actually coming out and going into this box over here. This is actually a camera. Let me see here. So we are actually right now not using this camera as a camera, believe it or not. We're actually using it as a USB hub, so to speak, because here's a camera, okay, and its output is USB, and we plug that into this camera, which then feeds into the router. So it's kind of a little weird. The other way to do it, of course, is to plug the camera directly into the Rio, into the RoboRio. So we had our reasons for doing it this way. It's not important to talk about that now. I think that covers the electronics, or most of it. This is an example of a typical FRC battery. This particular one is retired. You can see that we got it in 2018, and after 2 years, it kind of conked out on us. You have to tape these over to protect from shorting, accidentally shorting out the terminals. and these are the Anderson connectors. This connector, as you may remember, fits into that red connector right there. Okay, so the idea is you can snap those in. You never have to worry about which way is right, which is the right way to put it in, because you already have the red to the red, the black to the black, so everything is always going to be correct. These weigh about 13 pounds. They do not count on your weight budget for the robot, but obviously you have to be sure that you account for that when your members of your team have to lift this robot onto the playing field, because 13 pounds is not chump change. Our robot is actually sitting in something called a robot cart, and for us the robot cart is just some plywood with 4 wheels on it, and this was made so that we can put just about any type or size robot that we might possibly build, and just be able to wheel it around. You must have some sort of a cart to move your robot between the pit area and the playing field. You can't just drive or push the robot itself. So you need a cart. Our cart has spots back here for extra batteries and a little shelf here for tools. But again, what you make is strictly up to you. As a hint, I would say don't make your cart bigger than the width of a door. In fact, you probably shouldn't make your robot wider than the width of a door, or else good luck getting it out the doors. This concludes part 2 of this video series. Be sure to jot down your questions for later Q&A.